In this video, we're going to have a quick look at normals. Normals are a very important part of 3D modeling, not only in the modeling process, but also when it comes to things like materials and rendering. So I think it's a good idea that we just have a good overview of how normals work. There are two types of normals associated with geometry. We have the polygon or surface normal, and we also have vertex normals. And we'll be looking at both of these in this video. So let's start with the polygon normal. Every polygon has a polygon or surface normal, and if I select this polygon here, go to my viewport settings, Shift V, and click the normals button, we can see this small white line appear in the center of our polygon, and this is the polygon normal. The polygon normal always points away from the surface of the polygon at 90 degrees, and it does this along the polygon's z-axis, represented by the blue handle here. And this is the default coordinate system of any given polygon, with z being the polygon depth. Now obviously this polygon doesn't have any depth at the moment, but if you were to extrude this polygon, the extrude tool would move along this z-axis. And indeed the surface normal is used in quite a few tools when modeling. For instance, it will also drive things like the smooth shift tool, and we also have a few dedicated tools here in the transform tools, which can be used to move, scale and rotate polygons around their surface normal, and we'll be having a look at them a little bit later on. The polygon normal is positioned at a point midway between every point on your polygon. So we have a square polygon here, so the polygon normal is slap bang in the middle of this square. But if I go to point mode and move one of these points in, and go back to polygon mode, you can see that the polygon normal position has now moved to the average distance between all 4 points, while the axis has stayed where it is. Now this is because the axis is positioned at the center of this object's bounding box, which we can see here if we go to box, and all selected geometry will have one of these bounding boxes, and that is what the selected uses in the modeling axis. Now you can move the axis to the normal position, and you would do that by selecting points, as obviously this gives you the average distance between all 4 points on this polygon. So why is the polygon normal important? Well, it has one majorly important role in that it tells the application which direction the polygon is facing. And if you want this polygon to interact with the environment within Cinema 4D, Cinema 4D needs to know which way this polygon is facing. Now, one important aspect of this concept is the reverse normal. If I pan the camera round to the back of this polygon, you can see that it's blue, and this is showing us the reverse normal direction. Now, there's one specific feature linked to reverse normals. If I go to viewport view, I have this checkbox here called backface culling, and if I check this, you can see this polygon disappears. But at least it does until I pan the camera around to the forward-facing normal. Now, backface culling can be useful if you have a really heavy scene with lots of geometry. Backface culling will essentially allow you to discard any geometry that isn't facing the camera at render time. So essentially you will only calculate geometry that it can see the forward-facing normal on. And this can obviously free up a lot of resources. And reverse normals are also responsible for quite a few shading errors. If you ever see anything funky going on with your shading, the first thing you should do is select all your geometry and look for blue polygons. And then you can obviously reverse or align those normals, so everything is facing outward. Now, I just mentioned the word shading, and when it comes to shading geometry, this all lies in the hands of vertex normals. So let's check those out. Vertex normals don't really get much press in Cinema 4D, and that's because by default they are hidden from you. The only way that you can interact with vertex normals is via the Phong tag. And the Phong tag actually allows you to change the direction of vertex normals. Now, if we want to be able to see these, we need to use a plugin for this, and it's called the Vertex Normal tool, and you'll find this at frostsoft.blogspot.co.uk. They also make a Pixelberg viewport renderer. Now, I would suggest that you buy this plugin, as it can be quite handy at times, and this site has some great information on vertex normals and some really good tips on how to use this plugin. But for now, we just want to be able to see our vertex normal. So I'm going to go to my plugins list, select vertex normal tool, and then click in the viewport. And now you can see these normals appear in the viewport, much like the white line for the polygon normal. So what do these do? Well, essentially they control how this polygon is shaded. So at the moment, these vertex normals are pointing away from the polygon at 90 degrees. Like our polygon normal, and because all the angles are uniform, we are getting a very flat shading across this polygon. The thing to remember is that all of these vertex normals are independent from each other, and they all control a quadrant of this polygon. So if I move this polygon into the center of my viewport, and then I'm going to select the 2 points on the front end of this polygon, turn on my rotational gizmo, and watch what happens when I point these vertex normals at the camera. Now bear in mind that the default light in Cinema is positioned in exactly the same place as the camera. So as I rotate these round, you can see the shading is becoming more intense in this area of the polygon. And that's because these vertex normals are fooling Cinema into thinking that this area of the polygon is now bent towards it. And this is exactly how the Phong tag works. So in my viewport, I have 2 identical pieces of geometry, both made out of 2 polygons that are essentially at right angles to each other. Now on this version, we have this very smooth shading going over this transitional line, and this kind of shading we normally associate with the Phong tag. So what's actually going on under the hood here? On our first object, we have our Phong tag set at 80 degrees. Now this angle value is lower than 90 degrees, which is the angle of these 2 polygons. And if the Phong angle is lower, then the Phong tag is broken. Whereas on this version, our Phong tag is set at 91 degrees, which is higher than the angle of these 2 polygons, which is activating this Phong effect. So if I go to my plugins and select Vertex Normal tool, and we select both these objects, and I click in the viewport, we can see exactly what is happening to the vertex normals on this object. So let's make our length a little bit longer on our display. So on the version where the Phong tag is broken, the vertex normals along this transitional edge are being split into 2 distinct vertex normals. So each polygon has 4 uniform vertex normals, all pointing away from the polygon at 90 degrees, as does this polygon here. Now it's this split vertex which is causing this hard transitional edge. Whereas on our version here, when the Phong tag is active, it takes the 2 vertex normals associated with each polygon and merges them together and averages the angle of these vertex normals. And that average value is half of the transitional angle. So these 2 polygons are at 90 degrees, so the angle of this average normal is obviously 45 degrees. And obviously we can see if we point these vertex normals at the default light, we obviously get these gradient effects on each of these polygons. And that is how the Phong tag works its magic. Now, this averaging of normals is not only going to give us this sort of Phong shading we're seeing here, it's also going to affect how an HDRI reflects off of the surface of this object, because it's essentially bending the light information in this area. Now, I can actually mimic how the Phong tag is breaking in this plugin by choosing between the hard and soft settings here in the Vertex Normal commands. If I set this to hard, the vertices get split and are now facing at right angles to their respective polygons, and in soft mode they are obviously averaged at 45 degrees. Now if I get my rotational gizmo back and I rotate all of these vertex normals, you can see it gives the illusion that the light is travelling or moving across this object, but it's obviously not. We're just fooling the application into thinking it is. And this works in all manner of directions, like so. So you can see these vertex normals are quite powerful when it comes to shading, and also the way materials interact with your geometry. Now the problem with the Phong tag is that we only have one Phong tag, and sometimes when you're building a model, finding the perfect Phong setting for the entire model can be a bit cat and mouse. Now I have this very simple object here, and you can see the angles that are breaking the Phong tag because they have these hard transitional lines. And then down in this area we have this edge that's being smoothed off, and this edge here. So let's say I wanted to sharpen this edge here. I'd go up to my Phong tag and decrease the angle until I see a break happening in this area. The problem comes when I have an angle that is very shallow, like the angle across this edge here. And to break the top edge associated with that angle, I would have to bring my Phong tag down fairly low to about 16 degrees in order to get this to sharpen up. But what normally happens is you have other pieces of geometry. Let's say we want to bevel this edge, and I bevel this edge out. And now because our Phong angle has been set so low to break this edge, we're essentially destroying this area here, which should be a nice smooth shaded effect. And even putting this up by 1 degree is giving the effect we want here, but now we've ruined this area here. Now in applications like 3ds Max you have something called smoothing groups, which essentially allows you to add different Phong values to different areas on your mesh. Now we can kind of get around this in Cinema by selecting the edge we want to break, going to Mesh Normals, and I'm just going to tear this palette off, and I can simply say break Phong shading, which essentially splits the vertex normals on the points associated with this edge to give us this hard Phong break. And you can undo that by saying select broken Phong edges and just unbreaking them. So this menu here pretty much does exactly what our Vertex Normal tool does in the Vertex Normal commands by choosing a hard or split version or a soft and averaged version. Now the Phong tag can also be the cause of some pretty major shading errors, and this usually happens if you have your Phong tag set too high, because what this does is essentially it tries to average all the vertex normals on this object, and that results in some pretty funky shading issues, and we can see all those averaged vertices by selecting our vertex normal tool. All these points are averaged. We have some weird averaging going on around these areas with n-gon lines, and I suspect that's because they're not real lines and don't have real vertices attached to them, so they're not getting included in the averaging process. Whereas before, our vertices would look like this, with these hard breaks, and you can see all of the points have split vertex normals. And what we see here is that every hard polygon surface that isn't shaded has 4 vertex normals at uniform angles moving away from each surface at 90 degrees, giving us this hard shading. All shading errors associated with geometry are connected to normals in some way or another. So here are a few examples of some things to look out for, kind of common shading errors, and how you can go about fixing them. The first one is something like this, where we have this group of polygons that are obviously being shaded differently from the rest of our object. The main cause of this is usually reverse normals. If I select all the polygons on this sphere, you can obviously see that these normals are reversed. And the best way to correct this is to select all your polygons and hit UA, which is the key command for align normals. And this has obviously solved our problem. Two of the main causes of this reverse normal situation are the stitch and sew tool and the bridge tool. So I would suggest that once you've used these tools, you run a quick check on your normals after doing this. The second one is associated with the bevel tool. Let's say I want to bevel all the transitional edges on this cube. The best way for me to select these edges is actually by going to the Phong break selection. This will select any edges that reside on transitional edges that are breaking the Phong tag angle. Obviously all these edges are sitting on 90-degree transitions. Our Phong tag is set to 80, and that's how we're getting that selection. Now this is also incredibly useful for selecting polygon surfaces as well, and also points too. So let's say we select all those edges, then I go to my bevel tool, and we bevel this object. Now if we look at this object without the lines, you can see that the new geometry that's been added to this cube by the bevel tool looks very separated from these flat surfaces. Now this is because by default the bevel tool has Phong break rounding selected, which basically separates these surfaces from the new bevel geometry with a Phong break. And if we go to mesh, normals, select broken Phong edges, you can see the areas where the Phong break is occurring. Now to get rid of this, we could go mesh, normals, unbreak Phong rounding, and now that has got rid of the issue. Now I would actually suggest unchecking this and saving the bevel tool as default with this off, as you'll always end up having to go back and correct it otherwise. And you will also get this using the bevel deformer, where immediately we can see this Phong break rounding happening on all of this geometry. And if we come down here and turn it off, our problems go away. When you're dealing with low poly geometry, shading issues are pretty much a matter of course. And you can see on this shape, our top surface has some weird shading artifacts on this surface on the top. And this is just down to the fact that, you have polygons meeting other polygons at weird angles. And this basically affects the averaged normal angle at different corners of each polygon. And because these angles aren't uniform, we get these shading errors across the polygons. And your Phong tag really isn't going to solve this. In fact, on this object, if I move the Phong angle down, you can see this kind of rippling effect that we get as the Phong angle moves through all these different angles associated with this shape. So how do you go about fixing something like this? So this would be a job for the Vertex Normal tool, and what I can do here is select all the surfaces that aren't the bevels, and we can obviously see here that these Vertex Normal directions are kind of all over the place. So what we can do is actually process these Vertex Normal directions for just these surfaces. And we do this using polygon and point inclusive selection mode. So what I would do here is just set these all to hard and then say average vertex. And what this does is it calculates these Vertex Normal directions without including these surfaces in the equation. And what we end up with is something a lot more uniform. Then I would invert this and then use the snap selected to unselected. And this is going to take all the Vertex Normal directions on our bevels and snap them to the Vertex Normal directions on the polygons we just corrected. And what you can see is that we get a much smoother result from this. So compared to our other model, and you can see this is a good way to correct this sort of thing. Now the Vertex Normal tool is pretty much primarily used for low poly objects. You wouldn't want to tackle a subdivided mesh with this, but it's great for correcting things that are going out as game assets, and it can also really help with the normal mapping process, albeit not in Cinema 4D. Now you also have to be aware that the Vertex Normal tool overwrites the Phong tag, and you'll have to make sure you export normals when you export your object out. Now you're going to run into these kind of shading errors all the time when modelling, especially when dealing with really low poly objects. And the Vertex Normal tool might not be a practical solution during the modelling process. Now I have a really low poly piece of geometry here. Maybe it's going to be a small detail on something, but I still want to give it a nice bevel around these edges. Now the reason we're getting a nice flat surface on this object is because all the polygons on the top of this object have these vertex normals associated with them that are all uniform at 90 degrees. Now watch what happens when I bevel this. You can immediately see as I start the bevel, I start to get this kind of blown out, rounded kind of shading on the top here. And we might find that we also get some sort of shading errors across this polygon. Now we're getting this because as we beveled, the vertices on our top edge here are being averaged. And now you can see that the vertex normal is not at 90 degrees and is also not at 90 degrees on this side. And this is why we're getting this strange shading across this top surface. So what I would like to be able to do is protect this 90-degree angle that was here before. So how do I do this? Well, what I would do is grab these top polygons and inner extrude them. Now what this does is gives me an extra edge with these vertex normals at 90 degrees here. So now what happens when I bevel is I bevel out kind of up to that line, and now I have a nice bevel, but the vertices on these top polygons are now protected by this edge. And you can see we have this 90-degree vertex normal on each corner of our polygon, and this is going to give us a really nice flat result on top of this geometry while still being able to create this nice bevel. And you can see this looks pretty good. Now this is only 93 polygons, this object. You could actually just bevel this once and you're still going to get a pretty good result. And if this detail is going to be at a distance, this is probably all you would need. And this is only 57 polygons, which is nothing. So this is just a really good technique for cleaning up these top surfaces and getting rid of that sort of rounded shading effect associated with the bevel tool and low poly geometry. Now you may say, why don't you just use Phong break shading on this? You know, what I could do is bevel out this object, select the top polygons, go outline selection here, mesh, normals, break, Phong shading. Now this is going to kind of give me the same effect, but you can see that we get this very, very detached look using Phong break shading. And if this is going to end up fairly close to the camera, this might not look very nice. Again, if you're far away, this may be fine, and it's a much simpler technique, but they do both have very different looks to them. And I generally prefer the smoother transition of the inner extrude version. But again, it's another option for you if you need it. Now earlier on I was talking about our normal move, scale and rotate tools. So let's have a look at these quickly. Now when you use your regular move, scale and rotate tools, they work on the entire selection. So obviously if I move, these are moving as a whole. And when I rotate, they rotate as a selection, etc. Now what these tools allow you to do is to control each polygon along its normal center. So in essence, every polygon has a unique axis which is based around this polygon normal. So you can see if I were to scale out these polygons like so, they're getting larger and larger and larger, or smaller and smaller and smaller, not only as a whole, but as individual polygons. Now if I choose normal scale, you'll notice that the polygons don't actually move, they just scale. And they are using the normal as the axis center. So same with normal rotate. When I rotate, this is actually rotating around the polygon z-axis. And when I do a normal move, this is obviously moving the polygons out along their z-axis. And you can see they're not getting any bigger, they're just moving in and out. Now there are many practical ways that you can use these tools, but you have to remember that they're fairly limited in what they can do. What I mean by this is the normal move tool can only move along the z-axis. The normal scale actually scales on X and Y simultaneously, so you can't use the individual bands on it. And normal rotate only rotates around the z-axis. Now, if you want to expand this functionality, you can actually go back to your regular tools and set the orientation to normal and check along normals. And this invokes all of the functionality of your normal tools in the regular move, scale and rotate tools. But now you have the added bonus that you can use the individual bands to scale these polygons from their normal center. So now our rotate can rotate on Y, X, and Z individually. And we also have the ability to move these polygons on the Z and X here. Quite sure how you'd use that, but interesting. So don't overlook these tools or the normal along normals functionality and your orientation, as there are plenty of practical uses for this. So here's a very quick example of how you might use these tools. Let's say we want to make some sort of grenade thing. We're going to make these little fragment pieces. I could do this with the bevel tool, but I'm going to demonstrate the normal tools. So first off, let's get our inner extrude preserve groups off. Just inner extrude these. Then I can grab my normal move tool and move all of these polygons out, like so. So let's say we wanted to make a change to the polygons in this row and we want to make them kind of narrower. So first of all, we need to just select the polygons in this row. Now we could do this by going to our rectangle selection tool, hitting Command and deselecting, like so. But that's not much use if you then want to make changes to here and then maybe work on this row, as you'd have to go around and select each polygon. Now, a great plugin for these kind of selections is Selections Suppletives, I think that's how you say it. And you'll find this at code.vonk.fr, and these guys make some really awesome plugins for cinema. And we have one here called Select by Polygon Size. So let's make sure my tolerance is set pretty low. Then I could select a polygon here, hit apply, and it will select all the polygons of the same size. So a really, really good selection plugin. So now I have my polygon selected. I could then go to my scale tool, normal along normals, and now I can start to make changes to these different rows, just getting the kind of look that I want. So a really great way for making changes on individual polygons that aren't necessarily connected but need to be processed kind of individually at the same time. So I advise a bit of experimentation with your normal tools and see what you can come up with. Now, I can't talk about normals without talking about normal maps. Normal maps are an incredibly useful thing in texturing for adding fine detail into your mesh that you don't necessarily want to model. And normal mapping is a massive part of a high poly to low poly workflow that you find in building assets for games. Obviously, poly count is a big issue in game engines, so we need to be able to add the detail without the high poly count. Now, what you want to do is have a high poly piece of geometry, and you basically want to normal project this onto an extremely low poly piece of geometry. And you would do this via a cage, which is another piece of geometry that sits above or outside your high poly detail, and then the application raycasts from the cage down through both pieces of geometry, compares the difference, and creates a normal map. Mind-bogglingly enough, Cinema 4D is the only 3D application on the market that can't do this. So what you end up doing is relying on third-party applications to normal map. So what I've done is gone into Substance Painter, baked out the normal map using this process, along with an ambient occlusion. And what you're seeing here is the result of that process, which looks, exactly like my high poly geometry. And I can obviously paint on this, etc. But back to Cinema 4D. So now I have my low poly geometry. I can create a texture, load in my normal map and my ambient occlusion, apply this texture to my low poly geometry, and voila, here it is. So you can see it's an incredible way to add detail to a model without actually having to add any geometry. So what this normal map contains is pretty much the directional information from our high poly geometry. And we have three colours that are blended together. We have green, red and blue. And these are just like the axes in a 3D program. Green represents lighting information from top to bottom, red is left to right, and blue is depth. So all of the pixels in this image have their own unique directional information. Each pixel is basically a normal. And when you apply this to a piece of low poly geometry, what you're actually doing is faking the way the light is interacting with this surface, which is what produces the illusion of depth and detail. Now, normal mapping does have its drawbacks. Obviously, as you get to a shallower angle, this can start to kind of fall apart. But when used sensibly, it is a very effective technique. Now, you shouldn't get normal mapping confused with bump mapping, which produces a similar effect, but the process it uses is very different, as bump mapping uses grayscale values to produce these kind of height effects. Now, there are ways to normal map in Cinema 4D, but they're highly restrictive and a really big nightmare to achieve. And because you can't raycast, it immediately puts things like floaters out of the equation. Now, what I have here, this detail in the middle, is actually floating above this geometry. It's not actually modelled into this other section. It's a separate piece. The thing about these floating objects is that this is what the normal map projection sees. It doesn't care if it's not attached to the other piece of geometry. It's just seeing these edges and adding that to the normal map. And this kind of floating geometry idea is also an incredible way of adding more detail without having to cut into your high poly mesh. So I think Maxon need to sort this out, because this is such a massive part of building assets for 3D games.